I would like to tell you about things on maps that are simple and mostly present, one way or the other. I intend to touch on surveying and triangulation, a little on laid paper, explain tiny notes tucked away in the margin of the map, show and explain some things related to wind and compass roses, discuss scale bars, talk a little bit about printing techniques, show some dedications to what we would call sponsors nowadays, and maybe cover a map projection and a few more items if there is time. Topics like map orientation, relative position of items and their distance and direction away from each other are important to know about. In the old days, some 500 years ago that is, surveyors spent the summer season outdoors, collecting data, and during the winter season, with its short daylight hours, little light from oil lamps and candles, they stayed indoors, organizing their data into something useful for the cartographer. Distances are also needed to publish a scale bar on the maps. And how did surveyors figure out these data? The waywiser. The waywiser you see on the right, that is the wheel that counts revolutions and so counts distances. You see scale bars in hours of walking distance at a defined speed, something like 7 kilometers an hour. You see rope lengths. You see the little cherub on the right. He is having a chain. Here you see the waywiser that counts the revolutions. Here you see the one for the directions. And here you see this little cherub. He is holding, hardly visible, but he's holding the chains. They are foldable metal chains for distance determination. You also have, like on the chart like this is a German chart, 1596 from Lezing, and there the scale is made in horse pass, thousands passes of a horse. The horse has a pedometer. We have here a compass rose, but in German it is called Niedergang for west, Aufgang for east, Mitternacht und Mittag. And you see here the scale bar. The scale bar has no numbers, but it says this mappa is abgeritten. It is abgeritten in 1,000 steps of the horse, and that equals a quarter of a mile. I will go on to triangulation. Triangulation is actually the only thing that helps you make a good chart. You need to start with a baseline, A to B in this one. You figure out landmarks. If there are no landmarks, you build one on a hilltop or on a high building. And so you can go and figure out the angle from A to C, from A to D, from B to D, from C, you go to point C, you can take a bearing on D. And you can also, if you have a chance, make a secondary baseline because the tolerances of the measurement accumulate, and after a certain time you have a point where you can make a secondary baseline which is easily measurable in distance again. And multiple bearings taken on triangulation will result in a large grid of triangles extendable over a whole country and giving cause to call this method triangulation. Louis XIV of France complains that this new technique in surveying France has cost him more land than any of his battles lost in war. The tolerances do compound, I talked about that already. And in the Netherlands, the church tower of Amersfoort served as a starting point for a grid of triangles originating from there and covering the whole country. I go on to laid paper. This regarding papyrus from Egypt and mulberry paper from Japan. The early European carrier for maps was vellum, hides from sheep, goat or calf. So the largest available portolans use calf skins. Paper was quite a bit cheaper and much easier to manufacture, but less durable, in particular for long-time use on board at sea. Base material for maps on paper consisted of fibers, mostly hemp or linen. Treating this material required a lot of clean water, and when in the end the fibers were made into a watery pulp, this was scooped up into a mesh wire receptacle to dry into a paper sheet. A dried sheet has irregular edges, the decal edge we call it, and is proof of being uncut paper. Handling the paper over a long time will affect the edges of the sheet, wear, skin crease, consistently touching paper sheets at the same spot when flipping pages, and that will generate the need to cut the edges again, clean and straight, making the decal disappear. Folding a sheet of paper into a smaller size will cause the decal edge not to show on all sides. Holding up a sheet of gecept papier woven over laid paper against the light will show a grid of laid and chain lines either about an inch apart or perpendicular to them about 1 millimeter apart, caused by the mesh wire of the receptacle for the watery pulp. Also, a watermark may be shown, as producers of paper wanted to protect and advertise their own paper, and so made it identifiable by pressing thin, flat copper strips into the watery pulp. These show up as watermark. Watermarks may be identified by consulting the relevant literature. Famous ones are Hewood, Churchill, and Laurentius in Holland. A note of caution also. Not all sheets of paper may carry a watermark, as normally one watermark was inserted on a full-size sheet of paper, and when a folio sheet is folded into a smaller size, your map may have a watermark, but other segments of the same sheet will not have one. When map sheets have been cut off too often, a restorer may have to provide a new margin from old paper, often the rim of a text page from the same atlas. The new laid and chain lines may not correctly line up with the old paper and give away the remargining. In general, a map contained in a book or atlas will be better protected than loose sheets that have been on the market repeatedly. After about 1800, paper quality was considerably degraded due to the use of wood pulp instead of hemp and linen. Origin giveaways are next. Putting in a historical map into perspective is made a lot easier when we know who made the map and when it was made approximately. Makers of woodblock images were rarely mentioned. On the copper plate, it became much easier to mention the names of the maker. The cartouches would carry the impression of the publishing company and of the names of the maker in the drawing that had been engraved by the engraver, but mostly the map maker's name might appear somewhere tucked away in the margin of the image. A number of editions may point at the tasks performed, mostly in Latin and often abbreviated. Sculpsit stands for engraved, syllabit is engraved by, delineavit for draftsman, depinxit for the painter, excudebat for publisher, facit for maker, fecit aquaforti for the etcher, and infinite for the designer. A few extras. Apud means by, ex officina means at the workshop, sumptibus tells you who paid for it all. A mandatus reveals amendments or improvements. When that happened in many places, it will say multilocis. Scales may be in miles, in mille passum for 1,000 steps. Virge stands for rods or roede in Dutch, and the units of the scale will be specified in several types of miles, Werst in Russia, and Toise in France. All of the above may have been abbreviated, adding to your confusion maybe. Colorists are hardly ever mentioned, but I'll leave that to Truusje Goedings on the lecture in the evening, in the afternoon. A Visser copper plate is next. As case in point, it is made by Visser on the upper right. Let me try the, here it says made by Johannes Visser, and I and a J are the same. This is a Mercator chart, which means there is no space in the map for both polar areas, so there are two polar areas in a different projection in the lower corners of the map. And if I go on to the next detail, you will see that to the left, here it says Klaas Janszoon Visser Escoudebad in 1652. That's one of those. And on the right, you see here, by the way, the daylight, the maximum hours of daylight depended on the latitude. Compass roses are next. First of all, compass roses are more likely shown on sea charts than on the topographical charts, as they play an important role in navigation on the high seas. For topographical charts, they provide orientation to the beholder, in particular when the orientation of the map is not self-explanatory, like on this Japanese map of Decima. Japanese room walls are of paper, unfit to display maps. And when sitting on the tatami around the map, orientation differs for everyone present. Please note, here is north for the Japanese chart. Here you see the sign for west. Here we have east, and south is over here. So that gives you an impression of the proper orientation. For cases where the stretch of land is not easily fit onto size of paper sheets or the animal skin in case of a vellum map, orientation needs to be provided for sure. Mostly a compass rose is used and oriented for true north, the direction of the North Pole. Sometimes magnetic north is shown on multiple places on the map through a smaller, simpler compass rose, well distinguishable from the true north rose. I need to point out that there exists a basic difference between wind roses and compass roses, although in daily practice both words are used indiscriminately. Wind roses predate the compass rose, as they were applicable in the days where the compass was not yet available or not yet used for being too expensive. Wind roses originate from the Mediterranean Sea region, where the winds are rather identifiable as their direction is locally well known. To quote a few, here we have tramontana. North tramontana means in Italian behind the mountains. Basically it is used from Venice, and behind the mountains is east-west. Behind the mountains, so the direction is north. You have here the wind, the G is the wind from Greco, Greece. This is the cross that points to Jerusalem. S is the Sirocco for southeasterly winds. O is Ostro for south. L is the Libecchio, the wind from Libya. P is the Ponente, where the sun goes down. And M is the Maestrale, the northwesterly wind. Other references also exist, like Levante, Ponente, Maestrale, Sirocco. Well, I covered them all, I guess, but there are many more. Midi, we have Mezzogiorno in Italian, is midday. may also serve for south, as does middag on Dutch maps, septentrio for north, orient for east, midi or meridionale for south, and occident for west. I would like to show a compilation now. This is a 1655 wind map by Jansonius from his Sea Atlas in 1655. It is not a wind rose, it is not a compass rose, but it is a hybrid contraption. It shows for 6 different languages the directions according to the wind rose or according to the compass rose. You can see here, for instance, Maestro with his northwest. You see here the Scirocco for southeast, but you also see north. For instance, we here have north, norte, tramontana, septentrio, and something in Greek that I can't read anyway. The primary compass rose is mostly located in the middle of the ocean and not much decorated, as this would hinder navigation. Nicely embellished roses are to be found over land areas where ship's navigation could not be affected. But on topographical maps, the system works the other way around. Modern compass roses have 360 degrees of direction, but older ones are subdivided into 16, 32 or 64 compass points, streken in Dutch, with 32 being the more common option, suitable to the ships under sail, where courses kept will fluctuate according to wind shifts. Dividing the circle accurately into compass points was difficult to do, even more so when the lines have to be engraved in the copper plates. Therefore, very inaccurate divisions occur, like the one that's on the screen now. The best way to construct a good subdivision is by halving an angle using a pair of dividers. The word divider is pointing at its use and also at its results. This way, a straight line may yield. The drawing is not very nice, I'll admit, but the principle is on it, I guess. The straight line may yield 90 degrees. If the halving days, you get 45 degrees. Halving them again, you get 22.5 degrees. And the last halving is to 11.25 degrees. And that is the compass point or streek. Around 1780, a dividing engine or machine was constructed by Jesse Ramsden in 1773 and Troughton in 1778 in England, capable of dividing a circle into 10 minutes of arc using 2,160 teeth on the machine, readable to 5 seconds of arc using its micrometer. This made the halving method obsolete at last. Winds cannot serve as a directional reference on the world's oceans outside the Mediterranean. As we cannot navigate the oceans without compass and scale bar, it is only logical to steer according to compass directions, cardinal direction north, south, east, west, and the halves more intermediate courses. You see, here we see scale bars. There's a ghost chart. And you see 3 scale bars, I think. No, it's only 2. German miles and Spanish miles. The German mile is 15 to a degree of latitude, and a degree of latitude is about 110 kilometers. So a German mile is 7.4 kilometers. And Hispanic miles are 17.5 in a degree of latitude. So they're slightly smaller. Direction north on the compass, is identified by a special mark, mostly longer and more elaborate than the other compass points, and decorated, for instance, with the fleur-de-lis. East often carries a smaller token mark, indicating Jerusalem. But east of Jerusalem, this mark is not reversed, and this points away from Jerusalem, barring the concept that continuing east may still bring you to Jerusalem the long way around the globe. So much about wind and compass roses. Do not forget to apply the variation between true north and magnetic north, and you will be all right on compass roses. On scale bars, well, we have here scale bars already. We have more scale bars to come. Here we see 3, the German miles, the Spanish miles of 17.5 in a degree, and the English and French miles are even smaller, 20 to a degree of latitude. We also have other scale bars. I'll give you here a Mercator chart by Van Keulen, and on the top left you see a scale bar for a Mercator chart, because a scale bar on a Mercator chart is depending on latitude. The detail shows it here, and actually the scale changes with the cosine of the latitude, which means that the scale at 60 degrees north is twice the scale of the equator. If you think that was all, there are 8 scale bars on a Coronelli map. There is a scale bar for the distance you cover by walking a day. There is a scale bar for hours of walking. There are all the other scale bars and a few more. The German mile, by the way, is 7.4 kilometers, as I said, and that happens to be the average speed of a VOC vessel, about 4 knots we call it then, because we measure in knots on board, but 4 knots is about equal to 1 German mile. I would like to change to printing, and that is probably known to most of you already. Before there was printing, the maps were only existing as a one unique piece. But if you needed more, you would have to copy them by hand. That was mostly done by monks in a cloister or by people not making much in terms of wages. After invention of the printing method, we had maps since 1560 in woodcut printing, from there until about 1820 in copper engraving, after 1820 lithography, and nowadays we have this digital scanning and printing. Printing was invented, we thought, by Laurens Janszoon Koster in Haarlem, but it seems that Gutenberg in Mainz was the real inventor. Printing in woodblock is what we call hoogdruk. You cut away the wood that you don't want to touch the paper for printing with ink, and what is left behind is the hoogdruk, and that is inked and gives the impression. Hoogdruk is actually not using a high force. It is going onto the paper about 200, 250 times, and then you need to recut the block or make a new block altogether. If you go to copper plate, they can do with the burin, you scratch into the copper, you ink the whole plate, you clean the whole plate, but ink stays behind in the scratches, and you put a lot of pressure in the printing press on the paper and the copper plate, and then the paper will suck up the ink from the scratches. You can also, on the copper plate, do etching. Actually, the maps are normally engraved with the burin, and if you look at the etching, the cartouche is mostly etched, because in etching you cover the plate with a layer of wax, and you use a needle to make the image into the wax. And that is much easier if you have complicated lines like in a cartouche. It's much easier to do it the etching way instead of trying to do it in the burin copper straight away. Copper plates also have a wood block is difficult to change, because the wood will be Too soft, the wood will break off. So, but in the copper plate, it is easy to, or easier at least, to hammer out the wrong part from behind, then polish the copper plates from the front end, and then inscribe again the desired image. Now this is an example of a Mercator projection. I won't make it too difficult, but you see, in principle, a cylinder is put around the globe, and from the center of the Earth, you go from A to A accent on the map, from F to F accent on the map, G to G accent. You also see that if you do H, then it will be a very large map, very stretched towards the pole. And if you want to put a pole on a Mercator, you cannot do it because it needs infinity, and the map is infinite in size. I would like to also show a few funny things. This is an azimuthal projection. It's from the pole. Actually, the North Pole is in the center, and the outer rim, the outer circle, is South Pole. All of it is South Pole. You see here that this map has been made by Peter van der A in Lugdunum Batavorum, which means Leiden. I go to the next one, and then you see there is a little cherub up here holding also something with an asterisk. I have the detail here, and here it says that the asterisk denotes the positions that have been established by using the moons of Jupiter, which you cannot do on a ship, you can do on land. On a ship you can very easily make a coastline and make the coastline, but you don't know where to put it in longitude. So if you take, for instance, Cape Comorin, south of India, or Cape of Good Hope, south of Africa, you can have coastlines on both sides which are correct, but they are not correct in terms of latitude. The cartographers will tell you. But if you know where the Cape of Good Hope or Cape Comorin is laid, you can easily connect those coastlines, and they become fairly accurate in longitude as well. Here we see Blau's map of West Africa, and we see on this Guinea, on the lower left, there is a detail which I will show you. It says that this map has been dedicated to Dr. Nicolaas Tulp. We know the guy from Rembrandt's painting, the Annotation. And that is actually only a reason to raise money to make the map, because those maps are very easy and risky financially to make. And in Holland, mostly it is an authority that gives an order to make one, or a water board in Holland maybe, but it helps. In this case, Dr. Tulp, he probably paid something as well. I have another one. There's Fireland, Strait Le Maire, and so on, Jansonius. You see on the upper right, you see the dedication. It is dedicated to Walter de Raad, who was Hof van Holland as The Hague, and he was an eminent senator of West Frisia and Zeeland. Again, I can show you many more of those, but I will not in view of the time. I'll have a funny thing here. This is a nice map of Artelius, 1589, this one. The Victoria, the ship of Le Maire, you find here in the middle, with a complimentary note by Mr. Artelius. But the reason I show it to you is here, New Guinea, the next one, because we know that all of the Japanese, Chinese, Philippine, Indonesian, Thai people, they have sleek hair. But here in 1589, somebody has been there and has noted that the Papuans in New Guinea have small tails. He calls it the terra, the land of the people with the small tails, Picina Coli. I have another one by Nortelius, and I would like to point you direction somewhere here, of which I have the detail. and it says pygmy hic habitant. Hier wonen pygmeeën. Now, I don't know how that came about. It's already in the MacArthur world map from 1569, actually. But I think if you sail along the coast and you look through your telescope and you see 3 Eskimos and a dog sled, the Eskimos are not too tall, and if they're up to their knees in snow, it is very easy to note in the journal, pygmies live here. I'm almost at the end, ladies and gentlemen. Here we see on the left, this is a detail of a map that I'll show you hereafter. On the left, you have the scale bar and also a scale bar in hours of walking. You see that there is a little compass rose for orientation. You see it has been dedicated to Prince Maurits because this map was made in 1622 after the end of the 12-jarig bestand, the 12-year truce. And we wanted to be really clobbering the Spanish and the Portuguese if need be. This map sold well from 1622 to 1633. Then there were no more maps. They printed it anew. And it sold well until 1648. And then they ran out of maps again. But we had the Treaty of Munster in 1648. So there was a new issue of this map. And they didn't even bother to make it Frederik Hendrik instead of Maurits, because Prince Maurits died in 1625 already. This is the map, the Leo Hollandicus by Visser, 1622, 1633, 1648. I think it's a very nice map, and I think by now it is about time to take you out of the lecture room and let you go into the map fair and try to find the map that you couldn't find before. And apart from making me happy by being here, you can make the dealers happy by buying a map, I guess. Thank you very much.